Next, we're going to talk about section 8.4, which is binomial probability. With this type of probability, there is only two possible outcomes, success and failure. When we're talking about success and failure, that means that success means you get the outcome you want, and anything other than that outcome is considered a failure. So a very basic example of this is flipping a coin. Heads is a success and tails is a failure. Then you have, of course, something like rolling a die. Rolling a die can be considered a Bernoulli trial if you only have one thing that you're looking for. If you're looking for the number 3, that is a success. Anything other than a 3 is going to be a failure. Okay. Same thing with voting. If you vote for candidate A, that's a success. Anything else is a failure. Okay. So there could be other different types of outcomes. This just depends on how you're categorizing the outcomes. These right here are what we call Bernoulli trials, because Jacob Bernoulli, who lived from the years 1654 and 1705, figured out a way to always find the probability very quickly when dealing with these types of problems. Now, whenever you're looking at this, when we're talking about success, that's always going to be your probability P, and failure is going to be your probability Q, or in other words, 1 minus P, the probability of something not happening. Now, if you want to see this manually written out, we have that example here in the notes, okay, where you can figure out every single possible outcome that happens and then count up how many times you had a success, but that takes way too long. So instead, what we can do is we can look at a formula. The formula that we use anytime we're talking about binomial probability is going to be this one right here. Your probability of x equaling r, where x is going to be the number of successes. So here it's saying the probability of having r successes equals NCR times the probability to the r power times q to the n minus r power, where n is the number of trials, r is the number of specific events you wish to obtain, p is the probability that event will occur, and q is the probability that event will not occur. And as we just said, in your book, instead of writing q, they write 1 minus p, which is just the complement of the event. Okay, so it's still the exact same formula. So for example, let's look at this first problem. A test consists of 10 multiple choice questions with 5 choices for each question. As an experiment, you guess on each and every answer without even reading the question. What's the probability of getting exactly 6 questions correct on this test? When you see exactly, that's telling you what your x is going to equal. It says x equals 6. Okay, and that's because you want 6 out of the 10 questions correct. So what is your n? Your n is the total number of options, or the total number of test questions you have. So in this case, your n is going to be 10, and your r is going to be the number of questions you want correct. So in this case, you want, it says you want exactly 6 questions correct, so that means your r is going to be 6. And your p, which is the probability of getting a question correct, is going to be 1/5. Now, how did we get the 1/5? Well, it says right here, it says you have a multiple choice question with 5 choices for each question. So the probability of getting a question correct is 1 out of those 5 choices, so it's 1/5. So which means if you want the probability of not getting success, or in other words, the probability of getting it wrong, is going to be 4 out of 5. So how do we actually figure out what the probability is overall? Well, we use the formula above. You had your P of x equals 6. So the probability of getting 6 correct is going to be your NCR. And if you don't see it, just look above. So you have your NCR. So your N, which is going to be your 10, C, R, which is going to be 6, times the probability, which is 1/5, to the R power, the probability of getting 6 right, so it's 1/5 to the 6th power, and the probability of getting it wrong, which is going to be 4/5. And how many of those problems are we going to get wrong? Well, if we get 6 correct, we have 10 minus 6 wrong, or in other words, that's going to say we're getting 4 wrong. Now all we do is solve it out. So you have your 10 choose 6. Well, your 10 choose 6, if you put it into a calculator, is going to be your 210 times your 1/5 to the 6th power times your 4/5 to the 6th, or to the 4th power. Now be very careful when you plug this into a calculator. Make sure you have parentheses around your fraction, otherwise you will come out with the wrong answer. Now when you type all this into the calculator, you'll get 0.0055 and so on, which rounds to about 0.006. Or in other words, if you randomly guess on a 10 question multiple choice test with 5 choices for each question, you're going to have a 0.6% chance of getting 6 of those questions correct. So let's do a couple more questions. When rolling a die 100 times, what is the probability of rolling a 4 exactly 4 times? So your success is rolling a 4. Okay, so now we just have to figure everything out. So we have our P of your probability of getting how many right? Well, it says exactly 25 successes, so your X is going to equal 25. So now we need to know what our N is. Well, your N is how many times are we repeating this experiment? Well, you said 100 times. Your R is going to be how many of those 100 times do you want to get a success? Well, it says 25 times. So your R is going to equal 25. Your P is going to be the probability of getting a success. What's the probability of rolling a 4? Well, you have 1 out of your 6 sides is going to be a 4, so you have a probability of 1/6. And your Q is just going to be 1 minus 1/6. Is the probability of not getting a 4, and that's going to be 5 out of 6 sides are going to be a number other than 4. So what we do is we plug it into our formula. So you have your P, or your probability of X equaling R, equals your NCR times your probability of getting it right, R times, so P to the R power, times the probability of getting it wrong to the N minus R power, or in other words, the probability of getting it wrong to the number of times you're going to get it wrong. Okay, so if we plug everything in, you end up having your N, which is 100, choose 25, with a probability times the probability of getting it right, which is 1/6 to the 25th power, times your 5/6 to the how many times, if you get 25 of them right, that means you have to get 75 of them wrong. And if you go ahead and plug that into a calculator, you get your 0.0098. Okay, or if you want to round that, it's going to be 0.01. Or in other words, that means that you have about a 1% chance of getting 25 4s when rolling a die 100 times. Okay, so let's look at a couple more problems. Okay, so looking at this next problem, we have a certain intersection. The light for an eastbound traffic is red for 15 seconds, yellow for 5 seconds, and green for 30 seconds. Find the probability that out of the next 8 eastbound cars that arrive randomly at the light, exactly 3 will be stopped by a red light. Okay, so first thing you need to figure out is the total amount of time that we're dealing with. We have 15 seconds for the red, plus 5 seconds for the yellow, plus 30 seconds for the green. So that means we have a total of 50 seconds for that interval. Okay, so what we want to find is the probability that exactly 3 cars will be stopped. So we have the probability that X is going to be 3. Okay, where your N is the number of cars that we're dealing with, so it says the next 8 eastbound cars, so N equals 8. Your R, how many is going to get stopped by the light? 3. And now you want your probability. Well, remember, we're looking for the probability that you get a red light. Well, it says that you're going to have a red light for 15 seconds. So that's going to be 15 seconds out of the total amount of time for you to have a red, a yellow, and a green all together. So it's going to be 15 over 50. Or in other words, the same thing as saying 3 over 10. So if you have a 3 out of 10 chance of getting the red light, that means you have a 7 out of 10 chance of getting anything but a red light. So now we plug it into our formula. Remember, our formula is going to be your NCR with your probability to the R power times the probability of it not happening to the N minus R power. So it's going to be 8 choose 3 times the probability of it happening, which is 3 over 10. And 3 of those cars are going to hit the red light, so it's 3 over 10 to the 3rd power, times your 7 over 10, which is the probability of it not happening, and the other cars that do not hit the red light is going to be 5. So when you plug this into a calculator, you should get your 0.254, or in other words, you have a 25.4% chance that exactly 3 of the 8 cars will be stopped at this light. So let's look at this next example. In a certain state, it has been shown that 60% of high school graduates who are capable of college work actually enroll in colleges. Find the probability that among the 9 capable high school graduates in the state, that less than 3 of them will enroll in college. Okay, so if you're talking about less than 3, that's a probability that x is going to be less than 3. Well, in this particular situation, especially with binomial probabilities, you can't have less than. You have to break it up. So the less than 3 is going to be the same thing as saying that the probability that you'll have 0 people who enroll in college, plus the probability that 1 person will enroll in college, plus the probability that 2 people will enroll in colleges. Well, that's going to be less than 3 because you could be probability of 0 or the probability of 1 or the probability of 2, and or means to add them all together. Now I've kind of already done this on the side so we can save time, and we have all the probabilities of those, and since we're looking for all of those values, all we're going to do is add them together. So you have your 0, so the probability that x will equal 0, or in other words the probability that 0 people will go to college, is going to be 0.00066, plus the probability of 1 person going to college is going to be 0.008847, plus the probability that 2 people will go to college is 0.053084. And if we add these all together, okay, it's going to be about our 0.0626. So this is telling you that you have about a 6.26% chance that less than 3 of the students who are eligible to go to college are going to go to college. So what if you want to say more than 2 will enroll in college? Well, instead of saying more than 2, so that means you could be 3, 4, 5, 6, 7, 8, or 9. That's ridiculous. It's way too much work. So instead we do a shortcut. Remember, anytime you're dealing with a not situation, the probability that something will happen is the same thing as saying 1 minus the probability that that event will not happen. Okay, so that means we can go ahead and solve this by saying the probability that x is going to be greater than 2, or in other words, the probability that more than 2 people will enroll in college is going to equal 1 minus the probability that less than or equal to 2 people will enroll in college. Okay, so that's going to be your 1 minus, well, that's going to be the probability that x equals 0, plus the probability that x equals 1, plus the probability that x equals 2. And remember, this is the probability that 0 people will go to college, probability that 1 person will go to college, probability that 2 people will go to college. And since we don't want that, we're going to subtract that from 1, which is the probability that everything will happen. So you have 1 minus, well, we found that value last time, so it's going to be our 0.0626. And we solve that out. We have 0.9374, which is just telling us that about there's a 93.74% chance that more than 2 people will enroll in college who are eligible to go to college. And that's a pretty good chance. Okay, so let's look at this very last example. The probability that a birth will result in twins is 0.012. Assuming independence, perhaps not a valid assumption, what is the probability that out of 50 births in a new hospital that there will be at most 2 sets of twins? Yet again, at most, that means that you want x is going to be less than or equal to 2, because at most means it could be 2 or less. So that means you could have 0 twin births, you could have 1 twin birth, or you could have 2 twin births. Okay. So what you do is you want to go ahead and calculate all these values out, So we need to figure out our P and our Q. Our P, well, it says that the probability that you will get a twin is going to be 0.012. So the probability of not getting twins is going to be 1 minus that amount, so you're going to have 0.988. The number of total births, well, it says that here that the probability out of 50 births, so n is going to be 50, and r is going to be the number of births, or number of births that result in twins. Well, for us, we want 0, 1, and 2. So what we do is if we go ahead and plug them into our formulas, which we have over here, we get our results. Well, because this is an OR situation, we're going to go ahead and add all these values together, and you'll get the probability where x is going to be less than or equal to 2. And when you add those values together, you get 0.9777, which says that we have a 97.77% chance that there will be at most 2 sets of twins that are born out of 50 births.